The overall goal of this procedure is to grow high dielectric constant crystalline perovskite oxides in a scalable process to function as gate oxides directly on germanium, a future microelectronics platform.
This method can answer key questions in the microelectronics field, which is, can crystalline oxides, which bond across the interface, produce films with extremely low trap densities and interface states? The main advantage of this technique is it's easy to implement in a manufacturing setting and should be readily extendable to three-dimensional device architectures.
Generally, individuals new to these methods will struggle because lack of familiarities with handling the precursors and adapting timing the sequence of produced steps for their particular hardware and reactor.
We first had the idea for this method when collaborators grew perovskites directly on germanium using molecular beam epitaxy, and we thought to adapt their process to atomic layer deposition.
Visual demonstration of this method is critical because the sample cleaning, transfer step, and timing need to be modified for other systems, while ensure a clean and reconstructed growth surface.
For this protocol, use a heavily doped N-type germanium if electrical measurements of the film are needed. Otherwise, all doping levels and dopant types are acceptable. Place a germanium substrate, polished side up, into a small beaker. Add about 1 centimeter of acetone, and place the beaker in a bath sonicator. Sonicate it for 10 minutes. Decant the majority of the acetone, but do not pour out or flip the germanium substrate. Then, rinse the walls of the beaker with